My name is Saul Harris from Cardiff Vale University Health Board. Welcome to my presentation on planned maintenance derogations and our risk management and learning journey. As I'm sure you're all aware, COVID has affected many of us. For clinical engineering, it's increased our planned maintenance, or PM for short, backlog for a multitude of reasonings, some of which are commissioning, changes or increases in equipment management duties, relocation of equipment for um, Nightingale hospitals, and also changes in operations within the hospitals themselves. Staff sickness is an obvious one during COVID, and also the introduction of restricted zoning areas, which spreads equipment more thin, makes them more um, uh, makes them less available for access for planned maintenance or any kind of maintenance really. So the UK Clinical Engineering Network came together to create a guidance document to address the backlog. Um, one of the key parts was their application of risk-based maintenance, which is, to simplify it, a risk assessment to determine the maintenance frequency, and part of one of their medium-term plans, so 6 to 24 months, they suggested the derogation of planned maintenance using risk-based maintenance. So that's effectively a delay in the frequency, a one-off delay. How we went about doing this, we applied the Plan, Do, Check, Act cycle to our risk assessments. For the planner stage, we identified devices using our valuable source of information, our asset management database, where we collated information such as the quantity of PMs, and also based on previous work we were able to get a cumulative amount of hours that group of PMs represents, and we would exclude fast sum, so anything that was life support or anecdotally just wasn't going to be viable, so small quantities of assets as a trade-off for the amount of time and effort that the risk assessment was going to be required. And then also we looked at potential overtime opportunities as another recommendation from the guidance document. Then we needed to investigate our records, which took a bit more time and effort. So we used qualitative analysis to look at any overdue PMs, again, easily extracting that data from all those work orders from our asset management database. And then we'd also extract the quantitative data. So we apply shorthand, very simplified fault coding to monitor key performance indicators. So things like electrical faults, mechanical faults, just easier to group them together. And then we bring this evidence to a decision group where we would have a back and forth to see what was an appropriate risk to take forward. We'd discuss in full. When we had decided to take it forward, we'd obviously go on to the do phase where we would perform changes on our asset management database. We communicate those changes to the technical staff and necessarily clinical staff. We'd attach the risk assessments to the equipment record so that everything's in a traceable manner, it's all auditable, and we know which equipment's been affected. And then onto the check phase, so we also identified surveillance criteria, which was very heavily reliant on quantitative data of our fault coding, where we would identify what was an important code to use as surveillance data. And then we go on to the act. So we haven't actually reached this stage yet, but it's the question of what would we do if anything fails our surveillance criteria. Well, we could roll back PMs, we could actively prioritize the PMs, and yes, it would affect our workflow, but this is part of the risk of taking on derogation of planned maintenance. Following our methodology, We identified three groups of devices that we assessed to be suitable for having their PMs derogated. You'll notice that some have multiple frequency PMs, of which we've only derogated some of them, and we will go into a bit of a brief explanation of what we did for each one, and just bear in mind that it is a brief. There is more to the risk assessment um, than what I'm going to talk about today. For portable suction units, why did we consider them suitable? Well, majority, especially in hospital, don't get a lot of use. We have wall suction as well as a backup. Um, Patients who have high usage, well, they have a backup unit themselves, determined as necessary by the respiratory team. Um, they also undergo 12 monthly checks by our experienced tech teams, and they also undergo a daily user check. So we determined that that would be enough to identify any of the faults. Qualitative data, well, overdue devices tend to have suffered mainly from physical damage, um, and any of the mechanical faults that we identified were during annual services anyway. Quantitative data, we determined that the PM that we derogated was mainly to address any mechanical faults, prevent any mechanical faults, as they were replacing wear and tear parts. And 29 might seem a lot, but when compared to a fleet of approximately 400, it's less than a percentage. So this was going to be used as our quantitative surveillance data. Onto CO2 modules. Why these? Well, microstreaming is clinically used as a guide. There are other parameters that are being monitored that have more priority. Um, Strategic changes are made using blood gas analysis. Um, and then in critical areas, ITU, there's one-to-one nursing, so there is that reassurance of constant monitoring. And also, for this particular group, we didn't, we excluded um, devices that had more functionality, so anything that analyzed anesthetic gases as well, we excluded from the group. Looking at the qualitative data, mostly there were no faults found, or rather what we found was that some data was not being recorded, and I'll get on to that in a moment. We looked at the incidents, and using keyword searches, we couldn't find any relevant instances in the last 5 years. Quantitative data, the PM checks the calibration fault is what we are going to use as the surveillance data. However, as mentioned, data wasn't being recorded. It seems manufacturer training changes, and what's some techs are doing that others aren't, and they've been told to calibrate and then check the calibration rather than what was initially being rolled out, which is check, calibrate if necessary, and then check again. So data was being hidden. So I then had to rely on thankfully, one of our techs had paper records, which they completed the procedure and found that 15% were out of calibration, and used that as our basis for surveillance data. And going on to the electrical surgical diathermy. Why these? Well, we're addressing the 6 monthly PMs that other models, modern models, seem to have a 12 monthly check on. Couldn't understand why particularly, and maybe it was something related to something from the 80s with old terrible capacitors that didn't last very long. We looked at field safe notices, couldn't find anything that indicated that they should be 6 months, like as with the Genius 3 thermometers. Looking at the qualitative data, there were very low failure rates, of which were mostly low voltage power supplies, and they would fail safe. So there's reassurance that the devices just wouldn't turn on when they failed. Quantitative data, again, the checks were looking at electrical and calibration faults, of which you can see there's very low uh, number of faults, and these would be our surveillance, part of our surveillance data. So speaking of surveillance, an update after 2 or 3 months. As you can see, given the number of units, our number of faults are actually quite low, and even for the portable suction, which seems to be coming up to the threshold, well, none of those were actually part of the derogated PM. So um, I think overall we're on for a win here. Um, and even more so, we managed to gain some learning from this from each device. So the portable suction, we saw that there was misclassification of fault coding. We 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 thought we determined that this wasn't enough to significantly affect our quantitative analysis, but we, as a result, implemented stricter teaching on around the fault coding. CO2 modules, we found that the maintenance procedure was potentially hiding some fault data, so that was changed and relayed to staff, and we have a more robust process for that now. And then electrical surgical diathermy. Um, we have the potential to change the frequency to 12 months rather than 6 months to reflect the current, what seems to be a current standard for these devices. And this overall seemed to be much more of a quality learning experience than just as well as a risk management learning. And um, this led to an impact on our service of approximately baseline saving of 322 hours, which is quite a lot, but probably actually is going to be a bit less because some of the planned maintenance were done early, specifically the CO2 modules, more so than we expected. But let's not forget, the main purpose is to derogate this time away from the current now so that the technical team can prioritize their workflow. Thank you for listening, and any questions?